we'll talk a little bit more about instantiating and destroying. So if you missed last week, all the code we wrote was we have the spawner object. It's possible I wrote more, but I lost that project, so I started over, and this is where I think we started from. So the spawner has a reference to a prefab, which is the bullet, and then when the game starts, it spawns it, and then it doesn't do anything else. And then the bullet has a movement, how much it, or what kind of move it does, and then every frame, the update function is called, and every frame it gets a reference to the transform and then moves its position. And so the transform is this guy up here, which controls the XYZ coordinates that everything is in. All right, so before I get into it, I also want to remind you guys, please interrupt me, please stop me if I say something, or if I go too fast, or if I go on a roll and don't take a breath for 5 minutes. Interrupt me if you have a question. Just say, hey Rich, can I butt in for a second? And by all means, you can. So to that end, does anybody have any questions before we begin? Cool. No problem. Again, stop me whenever you feel like it. So where we're at right now is when I play the game, the ball gets spawned in the center of the screen, and it just goes on forever. And we have a little bit of control over the ball in that we can control the speed of it. That's on this bullet. It's moving pretty fast, so you can see the gizmo that's kind of guiding it. If I just add a 0 here, we can increase the speed it goes. So what I want to do is I want to spawn more bullets every time a button gets pushed. So I'll give you an intro into the button system, or to the input system. So Unity does have a new input system, but I don't know how to use it. So we're going to use the old input system, which has been tried and true, which works, and it still works. If you're going to be brave and you're going to go into VR dev, this will not work for you. But if you're just getting started, then this is everything that you need. So what I want is the spawner object. The spawner is just something that just hangs out, and it has a reference to the bullet, which is in our prefabs folder. And right now, it has this event start. It's blue because Unity calls it, and it instantiates it. But we don't want to instantiate when the game starts. We want to instantiate when the player pushes a button. So what I'm going to do is I'm going to create an if statement. So if I'm going to hit the input class, which is pretty easy to find. It's just called input. And there's a few functions that we could do, but we're going to use get button. I like this one. So there's also get key, but we're going to talk about get button today because this plays well with Unity. So there's 3 different kinds. There's get button, there's get button down, and there's get button up. And if you're using Visual Studio, this little menu should pop up automatically for you, and it'll tell you the difference between them. So there's three versions. There's up, down, and then just get button. And they all depend on the state of the button. So the get button, it will return true while it's held down. So it's while. And then get button down returns true when only the frame that the button is actually pushed. And then get button up returns true only the frame that the button is released. So in this case, we're going to use down because I don't want to spawn a bullet every frame that I'm holding the button down, only just the time that I do it. So now we have to give it an argument. So we have to tell it what button to give. So before I do that, I'm going to pop up here into, I'm going to go edit, and I'm going to go to project settings. It's over here. There we go. And what I'm looking for is the so project settings are all of the meta settings about your project. You've got some audio settings, some editor settings, some physics, but what we're interested in is the input manager. So this is what defines, Unity already predefines a whole bunch of common inputs, stuff like horizontal, vertical, firing, jumping, mouse buttons. The names don't, so we use the names in code. So the name is what's important because that's what we're going to use when we script. A lot of this you can ignore, but we're going to use jump. I think that's a good one to use. So jump is the name of the input, and it uses the space bar. So anytime you press the space bar, then Unity knows that you've pressed the jump button. And we can name this whatever we want. I guess I'm going to call it shoot. And you can rename these all you want. You can reuse, like we could use fire one if you wanted to, but I like the space bar because it's just straightforward. So you can, of course, change these. You can say R if you press R, or space, whatever you want. And then you can play around with these settings as well, but the defaults are pretty good. So all I did was I changed the name of this to shoot instead of jump. And then I'm going to close it because that's all we really need to do there. But I will copy this, so that's part's important. So now when we're in here, what we need to do is put in quotes, because it's a string, the word shoot. So now it knows which button we're talking about. And then what I want to do is instantiate the ball. So now we'll come back into Unity, let it recompile. So this little thing's going to spin for a bit because it knows that the code changed. And then when I play the game, we should see nothing happen. And then I'm going to press the space bar, and there it goes. It spawns balls whenever I press the button. And you can see them over here. It says clone because these are all being built from this bullet prefab, and it's just being cloned and then sent. And so here I go. I'm just going to mash a whole bunch of buttons, shoot a whole bunch of balls. But if you notice, they never disappear. They just keep going forever, and that's fine. But eventually, we're going to run out of memory. Eventually, like on a long enough time scale, if we play this game for 10 hours and I have a happy trigger finger, these never get cleaned up. So that's a problem we got to solve. So the opposite of instantiate is destroy. So what we need to do is destroy game objects after a certain amount of time. So what I can do is this instantiate method returns a reference. So it spawns that thing bullet clone. We can get a reference to that. So if I do game object, and I'm just going to call it bullet clone. So now when it gets instantiated, I now have a reference to that new thing. And I'm going to call this function called destroy bullet clone. And there's two overrides. You can, if you just give it like this, it will just destroy it right away immediately, which doesn't make sense in our project. But you can also give it this other function which takes a float for time. And I'm just going to say 3 seconds, not 2 seconds. 2 seconds seems like a good amount of time. So now, same deal. I'm going to recompile it, hit play, and then if I spawn, you can see them go. And then, well, we lucked out pretty cool. They disappear right at the edge of the boundary, which is uncanny, but yeah, right before it. So now it cleans up these bullets, and now we have a game that can be played forever. We have solved the problem of a resource leak. Any questions up to this point so far?
I got a question.
Yeah, what's up, Adrian?
So like once you instantiate the bullet, right? Does it like load like on the spot, or does it like preload like when the game like compiles?
So when
This is the
I
resource for the
created
bullet,
the
yeah.
bullet, yeah. So this bullet I created like a couple weeks ago. I created a new game object, or I don't know. I created a sphere, and then I put a I'll just call this test bullet. So I created the bullet that I wanted, and then I took it and then I just dragged it into the project, into like my folder, and that created the prefab. So that singular prefab gets loaded when the game starts. So when the scene starts, Unity knows that there's a bullet, or it knows that this spawner references the bullet, so it goes ahead and loads that bullet when the scene loads, I believe. But then
All right.
you and I, since we're in this update function, it's loading the bullet, the frame that you call shoot, it's instantiating and like allocating space for that and stuff. Does
Oh, I
that answer your
see.
question?
Yeah, I got it. Yeah.
Yeah. So if so the natural consequence of that is we're instantiating something every on the fly is what we call it. So you might do well to create something like an object pool. Like this is like some next level programming stuff, but maybe you would instantiate 10 bullets and then choose one of those bullets when this goes, and then instantiate that one and have that one move. But you don't have to do that. That's like some fancy stuff. Like when you're ready to ship your game, you do stuff like that. But for the most part, this is what you need to get going.
I have another question. Is there like a
Sure.
way to like load the bullet like another time and then like so you don't have to load it later or something like that?
I'm not sure what you mean.
Like
Well,
load the resource for that bullet. That way, like let's say maybe you're trying to instant something that's like really big, right? And like once you instantiate it, it makes like a lag spike, I guess. So is there a way to like
it does.
preload it like beforehand and
Yeah.
then
So to preload an asset, you could do something. So I would do this. I would do a private game object, and I call it the spawn instance. And then when the game starts, we'll do instance is equal to spawn instance is equal to this, and then it's going to start like visible and moving. So what you might want to do is do spawn instance dot set active false. So every game object has this little button in the top corner, this little tick box. So here's the bullet, and if I want it like to hide it, I can. This is the set active boolean. So if you turn it off, it's still loaded because there it is in the hierarchy. It still exists, but it's not active. It's not doing anything. And then you can turn it on by setting it true. So then instead, so I set it false, and then down here I would say, I'll just do this and then copy this out. And set it to true. So this will only work for a single bullet because I'd have to instantiate, like I need a list of them, but this will kind of answer that question for you. So then we should see nothing. We should see the bullet start, but it's invisible. And then when I hit the space button, it turns it on, and there it goes and does this thing. So start gets called when the level is loaded. So typically that's during like a black screen or like a cutscene or something where it's safe to do some intensive resource loading. And then down here you do you just set it active instead of instantiating. So many ways to solve different problems. Does that answer your question, Adrian?
thanks. I hope I'm not taking much time. I'm just curious about Unity. I'm so used to
No, that's all
developing.
good. Yeah, 1 second. Take a sip. So yeah, if you're doing a ton of instantiating at runtime, that might be kind of heavy, or then maybe you want to do a technique like this. But for our purposes, we're going to get by with just this guy. Any other questions before I move on? Cool. No worries. So the next thing I want to do is have it hit something. And so let's create a target. So I'll just create a cube, make it super big so that I can't miss it. So I'm gonna click on this tool here, which is the everything tool. You can rotate and you can move and you can also scale. It's kind of tricky to see, but there's a square in the center, and if you pick the square, you can change its scale. So I'm just going to scale it this way. I'm going to scale it up this way. Just create a wall. It's really hard for us to miss. Cool. So what I want is when the bullet hits this wall, I want it to I want it to do what bullets do, and they stop. They just destroy. So if I shoot now, all these bullets are just going to pass right through it. So they hit it. Well, they do indeed pass, and then they're let's move it up just a little bit. There they go. So they go through it. What we want is for them to stop at the wall. So what we need are colliders, which all these things have. So our cube, I'm going to rename this our wall. It has a collider. And then our bullet prefab also has a collider. So they're almost ready to like handle collisions. We just need one thing. We need a rigid body. So I'm going to put this on the wall. So a rigid body tells the physics engine that this object has physics. So the rules of Unity is, in order for collisions to happen, both objects need a collision or a collider, and at least one of them needs a rigid body, because otherwise it's like a moving platform kind of thing where they're just moving. But if you want the physics engine to like react to collisions and stuff, then it needs a rigid body. So I'm going to turn off gravity so that it stays in place, and then it's all good to go. So I've been using Unity for a while, but I still have to check this guy. So I'll post this to you guys. It's a picture. It's a collision matrix. So there's a lot of different configurations you can do, but I just sanity. I just want to make sure I do this correctly. So yeah, they will. So rigid body and a rigid body or static collider. Yeah, so they will hit. So a static collider means it just has a collider, and a rigid body means it has a rigid body. So our ball is this one, and our wall is this one, so they will collide. And I'll pass this to you guys in a bit. So how do we know if it's going to collide? We have to do some scripting first. So let's go into our bullet script. And similarly to where Unity provides the start and update functions for us, they also provide two others, or many others. They do on collision enter and on collision exit. So these will be automatically called when the physics engine detects a collision. So just for our own sanity, I'm going to do this. I'm going to do debug.log and say collide. And I'm going to say stop collide. So debug.log is essentially printf, or print to screen. Unity has down here a console, and you can write to it, which is like the most basic debugging you can do. So if I hit this and I spawn some bullets, and we should see, oh, well, that counts. There they go. So it worked. So it knocked him over, but that's not what I wanted. I want the wall. Yeah, and then the balls should have collided. Yeah, rigid body, static collider. I tell you what if I inverted this? Sorry, I gotta experiment just a little bit. If I take off the rigid body from you, I add the rigid body onto the bullets. I want to play around with this and see if this does what I want it to do. Oh, close. All right, sorry, I just had to think for a second. So let me try one more thing. Let me do, instead of transform, let me change this to rigid body. Oh, because this is the spawner. That's why. Okay, of course. My bad. So I put the code in the wrong spot. I put the code on the spawner. I should have put it on the bullets. That makes sense. Thanks for your patience, guys. Put the rigid body back on here. Mask to a billion. Take the rigid body off the bullet. Aha, excellent. Okay. Perfect. No gravity. If I make it kinematic, will that work? No. Okay. Yeah, so this will fly. Okay, so sorry, go ahead.
Isn't the wall not
Did
supposed to
you?
move? Shouldn't it be like static or something? I think.
Yeah, I think if I mark it static, it should do that. No, it'll still do that. No, I'm gonna go back to this one. So I'm gonna put the ball. I'm gonna put the collider on the ball, or the rigid body on the ball. Actually, I think that is the way to do it. So no gravity on the ball. I just want them to fly. Yeah, there it goes. Okay. Cool. All right, so just kidding. No rigid body on the wall. I put the rigid body on the bullet. As only one of them need to have the body, and I chose the bullet in this case. And then the wall is marked static, so I just want the wall to just be there forever and not move. And then down here in the console, we do have all these events, all the collide events. So we get collide and stop collide. So these are really useful for if you need to know if you need to know when your player has jumped. Sometimes stop collide could be useful, or anytime something leaves, anytime the collision stops, then on collision exit will occur. All right, so then we want two things to happen when the bullet. So I'm going to remove this destroy code from the spawner. I'm going to move it to the bullet. So the bullet gets created. I'm going to use game object. So this bullet.cs component is on the bullet game object. And so the bullet, here's bullet.cs, but I want the whole thing. So to get the whole component or the whole game object, I use this game object variable. So otherwise it would just destroy the component, and I want to destroy the whole thing. So I'm going to say this is the lifetime, but then down here, if I hit something, then I want to destroy game object. And so this way they won't pool up on the bottom. They'll be destroyed as soon as they hit the wall. Ding, 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 ding. There they go. So then if I shoot a few, yeah, so now if so the game's running. If they hit the wall, they'll disappear. Then if I move the wall, oh, I can't move it because it's static. If I move the wall, then they'll still die after lifetime. So now they have both of that functionality applied. Any questions up to this part? Cool, no problem. So I'm going to keep the theme of a shooter here, but I will show you this much. So when I shoot the bullet, they go straight from where the camera's pointing. But if I twist the camera, if I twist the camera and shoot, they're still going the same direction. So the direction of the camera is not tied to the direction of the that the bullets get spawned at all. And I would like to fix that. So let's take our spawner component. I'm going to copy it, and I'm going to put it on the camera itself. Then I'll just right click anywhere and do paste component as new. And now here's that component down there. And this one I'll just disable it. I can delete it later if I want to, but I'll just disable it so that it's still there and I don't have to rebuild it. So now the bullets, what's happening with the bullets is that I'm taking give me a bullet, put you here and just disable you. So here's the movement. This is what tells it how much to move, the movement step, and I'm just setting it to 10. So every frame it's going to add 10 to the Z. So you can see that it's going to go 10, 20, 30, 40. Well, it won't be exactly that because I'm multiplying it by time.delta time, and this is something that you want to do anytime you're doing update code. So if you update runs once per frame, and so if your game is running at 30 frames per second on one machine, it'll move at a speed. But then if it's moving at 60 frames per second on another machine, it will move twice as fast. And that is not good. You want it to move like the same speed no matter which machine it's playing on. And also if there's if the game stutters, like for whatever reason, like if the frame rate drops, then you don't want it to like move half as slow. You want it to stay consistent. So multiplying your movement by time.delta time keeps it consistent no matter what is happening with the frame rate. So then we see that the bullets they just kind of add, they go by fast, but it's just adding to the Z. So that's not what we want. We want it to go forward. So we have a very cool thing we can do. We can do vector 3 forward direction. Actually, I don't need to do that. I can just do transform dot forward times movement. No. Oh, right. So instead of having the full movement, I don't want that. I just want a speed. So I don't need a vector 3, which is 3 floats. I just want 1 float. Float is just a data type for a number that has a decimal point. And I'm going to do this speed. So I will do time.delta time times speed. So this transform.forward line of code right here. So this is the transform. That's this guy here. Every component has a transform, and it's your position and orientation in space. And the forward axis is the blue axis. So any object with a like no matter which way it's pointing, the forward. If you say forward, you get the blue line. You can also do transform.up, and you can get the green line, and you can do transform.right, and you can get the red line. And if there is no transform.left, to get left, you just do negative right, because math, that's why. So we're going to tell the bullet to, instead of always going in a world direction, we're going to make it be a local direction. So it'll always move forward every frame. So let's try this out. If we run this, we should get exactly the same behavior until we start moving the camera. And then we should get some slightly cooler behavior. So everything looks to be exactly the same. But if I take the camera which has our spawner script on it, and I rotate it to go that way, and then I shoot. Ah, shucks. I expected it to do something different. Spawner's off. Oh, right. I know why that's going on. So it's because of the instantiate. So this version of instantiate, it just slaps the prefab right in the center of the screen, or right at 000. So all 000s in the world is right about here. So that's why everything's being placed there. So we want it to be relative to the camera. So what we'll do is we'll change this to instead say transform my transform, and we'll say my transform. So this version of instantiate it instantiates the object, and then it sets it as a child of the transform that you give it. So anytime that you want to reference a component in Unity, you got to use get component. So that is what gives us a reference to this transform. And then to set something as a child, so like as an example, I'll just create a sphere right here. Same color. Okay, yep. So there it is. So so to have something be a child, I'll make it a child of this plane. So see how it like indents it a little bit. And now if I move the plane, it's moving the ball with it. So the wall is not a child, so it stays there, but the sphere is a child of the plane, so it moves with the plane. So let's try that out. It's recompiling down here, and it's done. So we shoot, and that behaves like normal. And also, instead of spawning at the world 000, which is about right here, it's spawning on top of the camera, which is like local 000. So we get that weird effect where right when it starts like here. Wait, let's spawn it and then next. No, I can't do that. There. Well, it's kind of hard to tell, but it spawns like right on top of this. So then if I rotate the camera, point it over there and shoot. Aha! We have successfully changed the orientation. However, I have deliberately introduced a new bug, and that is since all the bullets are children of the player, if I rotate the camera, all the bullets rotate with it. So that could be cool if that's what you're intending to do, but that's not what we are intending to do. So we have to try something slightly different. So instead of setting it to be a child of the camera, we want it to be a child of the world, I guess. So instead what we're going to do is we're going to give it an override of a position and a rotation. So we'll say my transform dot position, and then my transform dot rotation. No, I don't want that. I don't want the rotation. Oh yeah, so we're gonna get a little funky real quick. I'm gonna use a new word that you may or not have heard before. It's called Quaternion Dot Identity. So quaternions are data structures that explain rotations in three-dimensional space. It's very similar to what you see over here with the X and Y to do pitch, raw, and yaw. So this is a funky word. It just means rotation. And then identity means none, or means 000. So we're essentially saying no rotation. So by saying no rotation, we're keeping it so that when this guy spawns, it spawns with 000 rotation. So that's what we're giving it. It's kind of funky, but we're by saying quaternion identity, we're saying no rotation at all. So we're still telling it to spawn at my current position with no rotation. So now it will no longer be a child of the camera, so that we won't have that problem of rotating where we rotate and everything else rotates, but we will still get the behavior of shooting straight ahead, and we rotate. Oh shoot, they still do that. So maybe I do need to give it the rotation. Yes, I do. So we'll do my transform dot rotation. So it all depends on what you want to do. Sometimes you want to give it no rotation, but in this case, I want it to be the same so that it shoots in that direction. So we'll recompile. Did it recompile? I believe so. So shoot forward, give me the camera and rotate, shoot forward. There we go. And then to prove my point, if you rotate now, it doesn't rotate all of the balls with it. The balls are free to move as they were with no influence of the camera. Cool. Any questions or any thoughts? Is there any part of that you'd like me to double back on and re-explain? Because I know that was kind of a lot we covered. We covered input, how to get input from the player and respond to it. We covered how to instantiate or create objects at runtime, and also how to create them like at load time. And we covered how to get like specific angles, like forward or right or left, and then how to be frame rate independent by using time.delta time. We also covered collisions. Well, all right. As you can see, game dev is pretty tough. You don't have to know how to use quaternions in order to game dev, but you kind of have to have an idea of what they mean and what they do. And that's kind of a theme a lot of here. You don't really have to know all of the details, but you slowly start to put it together and learn how to pay attention to what's important and what you need to get the job done. And as you see from me, as I consider myself an experienced game dev, and I still have trouble, right? I still have to think about what I want to do, and sometimes I use the wrong arguments and the wrong stuff. So all of that comes with time and experience and practice, and the more you use it, the more you know how to fix the common problems that you have.
Google is your friend.
Also, Google. You will never stop Googling. So if I did get stuck, something I would do is say I would type in Unity instantiate, and you can already tell I've been here more than a few times. So Unity has documentation galore, and it's pretty good. And so they tell you like all the different versions of the same code that you can use. There's a lot of different options that you can use. Here's the first one that we did, and then we did this one, and then we did this one, or we did this one, and it, oops, and yeah, it gives you descriptions, gives you example code. So here's pretty much what we did before, and this one even. Yep, it even uses input, just like we did.
Yeah, I think the most helpful thing are the code snippets.
For sure. Cool. Well, guys, thanks for listening to my spiel. Thanks for listening to this tutorial. If you would like more tutorials, please say so in the chat, or just like let us know. Because this was very like a beginner focused, but we do some more advanced stuff, and we cover components like UI and the Unity animator, and we cover a whole bunch of stuff, but we want to cover what you guys are interested in and what's applicable to you. So if this was too slow or too fast, let us know, and we can adjust these to fit what the needs of the club are. So if there's a topic that you would like a tutorial on, please let us know, and we will do so. Well, all right, everyone. Thanks for coming. Feel free to hang out and socialize, but this is like the end of the content, so feel free to stick around and just talk to each other and show off and whatever you guys do.